Hello to all of you, and special salam alaikum to people from Malaysia. And thank you very much for inviting me to give a keynote speech at International IEEE Conference on Biomedical Engineering and Sciences. Today, I will talk about the application of artificial intelligence in management of maintenance of medical devices. And yes, to introduce myself, my name is Almir Badnjevic, and I'm coming from Sarajevo, from Bosnia and Herzegovina. At the beginning, I will shortly give some basic information about me. First of all, I would like to share information with you that I'm one of the board members of Clinical Engineering Division, which is in fact the part of International Federation of Medical and Biological Engineering. And as you can see in this structure, we are one of the UN organization. Also related to IEEE, I'm one of the board member and in technical committee of the cardiopulmonary systems. Then also to as steering committee member in IEEE standards, and I think that we have some colleagues from Malaysia also in our committee here. From IEEE Engineering and Medical and Biological Society, I'm one of distinguished lecturer too, and those three topics are the topics where I am teaching, and one of those topics is also the topic which I'm talking to you right now. Related to my academia career, I'm working at the Faculty of Pharmacy and at University of Sarajevo, at Birch University, and also at University of Warwick in UK as the part of Professor Pecchia lab. Related to, let's say, business part, I'm director and founder of Medical Device Inspection or Verification Laboratory, VERLAB, which is in fact accredited per ISO 17020 and appointed by the country to perform annual inspection of medical devices in all healthcare institutions in our country. This VERLAB as a company established also the first one in the region, this part of the Europe, Research Institute for Biomedical Engineering, Medical Devices and Artificial Intelligence. That's in fact VERLAB Research Institute. And now currently we have 15 employed young people who are the young PhDs and PhD students, in fact with the masters also, who are working in this institute. In our institute, we also have something what is called the Digital Innovation Hub. It's called Lab Hub, and it's for Health Hub, which is performing the digital transformation of small and medium enterprises, especially in the public sector. I would like to use use this opportunity to invite all of you to join us and to send your papers on the conference. It's Medicon conference, and which is in fact Mediterranean Conference on Medical and Biological Engineering and Computing, and which is together with joint conference, which is International Conference on Medical and Biological Engineering in Bosnia and Herzegovina from 14 to 16 September next year in Sarajevo. So you are all more than welcome to come and visit us in Sarajevo and share all of your last research which you have. The deadline for the full paper submission is in fact the 1st March next year, so you have still time to write your articles. From academia part, I'm proud to say that I'm also the ordinary member of European Academy of Sciences and Arts, which is placed in Austria, Salzburg, and also I'm editor-in-chief together with my colleague Matthias in Technology and Healthcare Journal, which is published by the iOS Press. So if you have any of those articles which are in the part and which can go into the scope of this journal, of course, you are more than welcome to send your articles here. My lecture today is, let's say, divided in five different sections. The first section is definitely the current state and motivation, and what was in fact the motivation why we started with all topic. It's very simple, and I'm sure that all of you ask yourself when you were in the hospital, for example, in one city in your country, and when you go in the day 2 or 3 days later in different hospital, maybe even in the same city, why do you have to repeat all of your tests? For example, blood test, MRI, CT, RTG, etc., or even when you go from one hospital in one country to another hospital in another country, again, you have to repeat all of those tests. And that was the basic questions which we asked ourselves. Why do we need to repeat all of it if we already, for example, measure something, or we are already diagnosed with something, etc., etc. In that research, in discovering what's behind of it, we asked ourselves, in fact, are the measurements from the medical device the same everywhere? That was the basic question, because it's not because of the medical doctors, it's definitely because of the diagnosis which are get from some of the medical devices. And then we started first to check, is it the same everywhere in the Europe? And we found out that it is not really the same. Even they are using the same medical devices with each procedures, the measurements are not the same. And there is missing something what is called traceability. The same thing is also when we expand our research all over the world, and we found out that it is the same everywhere in the world, that medical devices measurement are not, in fact, let's say, standardized from the point of view of the output measurement and diagnosis. Why is that? We saw that we are missing, in fact, one very important things, and that's, in fact, again, the measurement. So we asked ourselves, so not anymore, is it the same everywhere? Because we know it's not the same everywhere. We asked ourselves, does it matter how it's measured? And then we come to one very, very often sentence which said, measure twice, cut once. If you want, in fact, to prevent different serious failures, disasters, and in fact, to ensure the purposes which should be fulfilled. And when we are talking about the importance of the measurement, of course, it's very important for confidence in the measurement. And if we are talking, for example, about some kind of the fuel, if we are talking about the gold, of course, they are talking a lot about the confidence in the measurement. But when we are talking about the medicine and medical devices, they don't really care too much about it. But like in every other part, we know once, and that's for sure. And that said, in God we trust, all other must bring data. So that's really true. So whatever we are talking, whatever other topic we are mentioning here, we must have data, and we must take care about how it's measured, from where we get those results, etc., etc. And then we made one experiment. We took 1 kilo of sugar, and when we sent it all over the world, and we proved that nobody didn't ask, is it really 1 kilo? They all accepted that 1 kilo of sugar without any problem. But when we took the baby, and when we put the baby in incubator, and when we wrote that the baby has 3.5 kilos in that incubator, and when we send that information to all other hospitals all over the world, we got information that they have to repeat that measurement. So we trust, in fact, without any asking in some kind of the sugar, because there is traceability, because the country is controlling that values in each scale. But when we are talking about the measurement in medicine, we didn't find that confidence there. Of course, when you ask many people who are in the field of the medical device, they will say, yeah, but the medical devices are the most strictly regulated, etc., etc. But in fact, when you check the information, especially, for example, information in MODE database, which is under the US FDA, or some media or something similar, you will find out, in fact, that it is regulated in pre-market, but after the pre-market, it is not in fact regulated. And even worse, we can in fact find that the millions of the injuries and thousands of deaths are in fact linked to some kind of the faulty medical device in the, for example, past decades. Also, what is very important to mention now at the beginning is that, for example, 30, 40 years ago, this left picture is something what described diagnostic of the patient, while today this right picture is in fact something what is describing diagnosis of today's patient. So what is the difference? The difference on the right picture, you have many devices and not so many human, while in the left picture, you don't have really much devices, but you have a lot of doctors or people who are, let's say, trying to diagnose something on this patient. But what didn't change the approach how to test medical devices, how to make the maintenance, etc., etc. And it should be changed. This is also in, of course, in accordance with the UN SDG goals, especially with the goal 3, which said that it's important to ensure the healthy lives and promote well-being for all at all ages. So our goal at the beginning was to implement some kind of accredited laboratory. We call it in Europe notified bodies, which will do inspection or verification of medical devices. But that inspection and verification should be established with the medical measurement traceability chain. So it means all the devices which we use should be calibrated, which will ensure to us accurate and reliable diagnosis and treatments. Of course, the benefit will have, first of all, the patient, which will be more protected, which will get accurate and reliable diagnosis and treatments. And of course, when we're looking from the point of view of the market, we would have control of the post-market of medical devices, and we should also decrease the maintenance of costs in healthcare institutions. So we started with development, and we figure out if we want to develop something related to medical devices and post-market surveillance, we should include the metrology, because we found out that the metrology is missing in this field. And if we want to use metrology in medical device, we have to carefully choose which standards we will use, because if we want to implement it on international level. So this is the definition of medical devices, and it's, let's say, the same almost everywhere. But the most important, for example, WHO, FDA, European Commission, they are using all the same definition. And what's very important to say that mostly we are using medical devices, in fact, for diagnosis and prevention, and also for the therapy. When we are looking the market of medical devices, we can say that, for example, there is almost 500,000 types of medical devices just on the EU market. So you can imagine how many different types do we have even at the world. And mostly some of the devices which we used at the beginning in our, let's say, pilot study and in our pilot research are those devices which are presented here, and we definitely can call them medical device with some kind of the measuring function, because all of those devices have some kind of the measuring function. When we're talking about the directives and regulation from 1992 up to 2017, we had something what is called medical device directive, and those directives they're mentioned on this slide. And definitely we can say that based on the medical device directive, pre-market was very well defined and it was working very good, while the post-market was totally given to, let's say, again, to the manufacturers, which wasn't controlled. While in the pre-market, they had some kind of the third-party independent body which checked all the standards and other things, while when the medical device is already on the market, that's post-market surveillance, we didn't have, in fact, any influence of the third-party independent bodies. So in 2017, we changed it, and in Europe from May of this year, it's enforced that medical device regulation is replaced medical device directive. Pre-market is pretty much the same, but the post-market has also something what is called the notified bodies, and which are in fact nothing else just the independent third-party bodies which has established laboratories, and which are doing not only the medical device, which are doing not only the monitoring, they're also trying to measure and to see what's happening with medical devices in their lifeline. In fact, what's happening with medical device in post-market surveillance. And when we watch at the current situation, even with new medical device regulation, we can say that we have pre-market very well defined. We have medical devices. After medical device, per medical device directive and medical device regulation, we have preventive maintenance, corrective maintenance, other things. But on the medical device regulation, we have something additional, which is in fact notified bodies. From information from both manufacturer and from the notified bodies, they're in fact coming to MAUDE database, and in European Union, it should go to something what is called EUDAMED database. And from all of those three sources, we should in fact use information to talk about the evidence-based maintenance of medical devices, and in fact to talk about the maintenance plan of medical devices. But when we watch at the current situation, we can say that all of those data from the notified bodies and even from the preventive maintenance, corrective maintenance are in fact unstandardized, incomplete, inaccurate, untimely, unverified, unreported, and in fact biased data. And that means, in fact, that, when we have the data, when we process those data, we are getting information, and from information, we are getting, in fact, some kind of the knowledge. If we want to get the good information, we should have very good data, but currently we definitely don't have data. I mentioned those problems with the data, and they're marked with the red letters here. So that's something what we have to solve if we want to have a good data in the ELDAMED, and if we want to talk about good evidence-based maintenance of medical devices. So then we move to the metrology. What is metrology? Definitely we can say per definition that's some kind of the science of the measurement, embracing both experimental and theoretical determination, and at any level of uncertainty in any field of science and technology. And when we watch at the metrology, we can say that we have scientific metrology, where we are talking about the new discoveries, etc., etc. Industrial metrology, which we can find definitely in industry when we want to calibrate something as pressure, flow, temperature, etc., etc. And the legal metrology, which is in fact related to verification and inspection, and it is always in every country. It means at national level, controlled by the country or some kind of the institute of metrology in that country. When we are talking about the metrology, the basic concepts here are uncertainty, which said how far it is in fact from our definition of that unit, about the traceability, which showed us what is that traceability chain, and which tell us again how what is that measurement, what's the point of that measurement in comparison with definition, and calibration, which is in fact some kind of the check, where we check one device and compare it with second device, and if we need to modify something, we modified it directly. In comparison with calibration, inspection or verification is just checking one more accurate device with another less accurate device, but we are not modifying anything. And the third term, which is interesting for us, is in fact the standardization. When we watch at those, let's say, the most important organizations which are taking care about the standardization, that's definitely ISO, then it's International Technical Commission, and also IEEE standards, which we mentioned there. And all of those organizations, they have their technical committees, which are working on developing some concrete standards. When I say concrete, I mean in some field concrete. And then every country can make adoption to national standards, and then from those national standards, by using citations and other things, you can get your, let's say, local or national technical regulation for it. When we are talking about the standards in medical device, definitely we can say that we have the basic safety standards, group safety standards, and product safety standards. Now, when we found out all of those things, then we come to the solution for it, and we found out that the medical devices, in fact, should be safety and should have good performance, which give us accuracy and reliability. To achieve that, we should use the etalons, which are calibrated in accordance with the ISO 17025 standards, which is in fact the standards for calibration. And based on that calibration, we will achieve the traceability. So our etalons will be calibrated with established traceability, and national bodies, notified bodies, should, that's the third part, independent bodies, should perform inspection in accordance with the ISO 17020 standard to do performance, visual, and safety checks of medical devices. Based on that, we are getting independence, we are getting a traceable measurement, and we are getting accurate information about the visual, safety, and performance parameters of all medical devices. Of course, this is also shown here, and all these concepts is in fact explained in the book, which is called Inspection of Medical Device for Regulatory Purposes, which is published by the spring 2017, when is also medical device regulation published. Next year, we will publish the second edition of it, and we will update all of those chapters with it. When we have it, then when we have established this solution, it means that every time when we have the patient, when we measure some parameters, when we are doing diagnosis of it, this device, for example, like this device, which looks like a patient monitor, is in fact, we measure that parameters on the patient by using this patient monitor. This patient monitor is calibrated per national laboratory. In fact, the laboratory which is doing inspection or verification, which is using etalons, which are calibrated by the National Metrology Institute, that's this Institute for Metrology of Bosnia and Herzegovina, which are using etalons to calibrate our etalons by the primary standards and international levels, which are in fact accredited and let's say realized and calibrated in comparison with the definitions of SI unit. So based on that, we know in every moment of our measurement how far is our measurement from definition of SI unit, and we can talk and we can say in fact now about the safety and about the performance and about the accuracy and traceability of our measurement, because we know in every moment what is our uncertainty. In EU, of course, there is already few different examples which are performing it. And of course, they are all related to National Institute for Accreditation, National Institute of Metrology, and National Institute for Standardization, where at the national level, all of those National Institute for Metrology published their rule books and show their legal metrology framework. They created then the inspection bodies which are performing it. And some of those laboratories are in fact mentioned here, and they are already performing different medical device verification or inspection, such as those devices which are in fact presented now on those two slides. Definitely, we can say that the goal of inspection or verification is to determine the output error, because by using those etalons, we are able, in fact, to determine was the error between the measurement on that medical devices and the accurate measurement from that etalon. For somebody who is not in this field, it's very important to mention that the inspection, which is defined per ISO 17020 standard, and verification are the same, let's say, terms. When you are measuring and when you are doing few years, you figure out that you have many data because you are measuring the parameters from all of those medical devices in all healthcare institutions, and then you figure out in fact that you need to let's say record all of those measurements in some kind of the digital databases. And then we created something what we call in fact eLab, and eLab is in fact the software which we are using for saving, recording all the measurement of all of medical devices. And in fact we allowed to all of our institutions, healthcare institutions, to check their devices to see is it verified or it's not verified. So they can check also what's, for example, history of their devices. They can check also which devices is working, which device is under the normal condition. They check. They can also, now they got also the list of all of those medical devices, because when we started measuring all of those devices first time, we wrote and we let's say we collected information about all of those devices, and now today we can say that we have probably a few million of the data in this very I can definitely say unique worldwide database in it. This is, for example of the certificate of inspection of verification. This is working order what the people who are working in the field what they open, and this is in fact the report from all of the measurement. You can see which device they use, you can see the visual inspection, you can see the electrical safety inspection. Now you can see also the performance inspection too. Some of the results which are important, so not just for the digitalization and other things, we can say that, and we can show that we had increase of the number of inspected devices from 1 year to another year. And of course, in the last few years, it's very constant from all of those healthcare institutions. What is also very important when you introduce and when you enforce the usage of calibrated devices for the inspection of medical devices, and when you introduce independent third-party laboratory or body which is appointed by the country, the faulty rate of medical devices definitely decrease a lot of it. And you can see also some of those results for different medical devices. And also you can see today how it looks like, how that change, how we keep this accurate device trend too. And also it's very, very important to, for example, mention that we decreased for all of those healthcare institutions and especially the clinical centers, which has a lot of medical devices. Here we have decreased in maintenance of medical devices because they didn't do the maintenance for the devices which are working perfectly good, and some of those distributors didn't change some parts if we show that device is working also very, very accurate. From this part, we come to the current and future research, and that's mostly something what is, let's say current, and that's something what is interesting for all of you. And for example, this is one document which is related also for one very country which is close to you in the part of Malaysia. It's Saudi Arabia, where we work also on implementation of different parts with the Saudi FDA. And for example, as you can see in their legislative responsibility, Saudi FDA has also something to appoint as 2, 3, and 4. For example, and 4 is to set policies and procedures for the medical device testing. It means independent testing. Then executive responsibilities, you can see it's testing of medical device, then establish a central reference laboratory for medical devices, then accreditation, licensing, establish medical device database, establish main research center, conduct research, conduct training programs, establish National Center for Medical Device Reporting, etc., etc. And as you can see here, most of those points are, in fact, definitely this what we already implemented and what I already presented to all of you. And we will come also to this research and other part. It's also in their strategy, and not just in Saudi Arabia and most of the countries in the MENA region. The same situation is there. But what is let's say the top thing currently at the world level is, in fact, how if we want to predict the future, you of course need the data. And in this let's say situation, in this case, we are generating data from device-related parameters, from parameters of electrical safety of devices, and from the parameters of the output. In fact, output parameters which are in fact related to performance of medical devices. So when we combine national regulatory framework for medical device inspection plus manufacturer reports and plus healthcare information, we got enough let's say enough data to be able, in fact, to perform evidence-based information. So this is how it looks like. We have medical device, we have healthcare institution, we have inspection bodies, such, for example, is this Verlab, such as other notified bodies which are there. They must use calibrated devices. We are calibrated our etalons in accordance with the SI up to SI definitions of SI units. We are regulated and controlled by the Institute of Certification or Accreditation and National Metrology Laboratory, and we are generating, in fact, all of those data there. When you have the bylaws and when you have the let's say defined methods how to measure something and with what to measure something, then we can talk about something what is necessary to be implemented. And now you remember I showed you one similar block diagram where I showed you what's the current problem with the EUDAMED database and other databases. And the current problem is that at international level, we don't have the standards for conformity assessment testing of medical devices, which all notified bodies will use. And then based on that, if we have it, we would have, and then the EUDAMED and other databases and international or European level would use standardized, complete, accurate, timely, verified, reported, and unbiased data. Based on that, we would be able, in fact, to implement evidence-based maintenance of medical devices. And because we will, as I said, just on European level, we have more than 500,000 of the types of medical devices. So after a few years, with the measurement, with many points of the measurement from each of that medical devices. We are talking about really big data. So mostly we are not using any more, let's say, just evidence-based maintenance of medical devices. We are in fact using, then we need to use artificial intelligence algorithms for the management of maintenance of medical devices. And based on that, we would get a medical device risk assessment, medical device maintenance plan, medical device cost effectiveness, and improve patient safety and quality of care, which is our main goal. So this is something what is missing. This gap is in fact the standards for conformity assessment testing. It means standards and standards procedure, how to perform inspection of especially performance parameters of medical devices. The same international standards for everyone at the end. Then we can talk about this question, which said how to understand the present. We understand the present, and I show you how what's in fact the solution, because this solution will give us a chance to change and predict the future. Of course, it's only possible because we are talking about the big data. It's only possible with the artificial intelligence, because without artificial intelligence, it's not so simple. Because we have a lot of experience in application of artificial intelligence, especially in diagnosis of different diseases in healthcare sector. And these are some of those publications which we already published. We started to implement also the artificial intelligence on our data, because we are lucky, because we are working on national bylaws, which has defined the standards for testing of performance. So we have already standardized data, which are recorded in our eLab software database. So we are able to prove this concept, and we are able, in fact, to predict and to use the artificial intelligence for prediction and for the management maintenance of medical devices. And some of those papers and articles are all, and our publications and results are already published there. And we proved, in fact, that we can go from the reactive to predictive post-market surveillance, what is, in fact, very important. And some of our results are, for example, published in the evidence-based clinical engineering, which is, in fact, machine learning algorithms for prediction of defibrillator performance, where we use the data, and then 2 years we use our software really in healthcare institutions, and we work on the prediction of performance of defibrillators. The same has been done also with the infant incubator study. We used, in fact, machine learning algorithms. Our input parameters was in fact, device-related information, such as visual inspection, such as reports from the maintenance, then electrical safety parameters and performance parameters, which we collected from our measurement. Then we played with some of it. We divided all of those databases. We choose it. We use different machine learning algorithms. And at the end, we in fact get very good result for our expert system. We also implemented the artificial intelligence, artificial neural network system for prediction of performance of infusion and perfuser pumps. We tested it, and we developed it on 1,738 different infusion and perfuser pumps, and we proved that it is working in let's say real environment, real healthcare institution in more than 98% of our cases. So that's all from my side. If you have any questions, this is my email. Please be free to contact me and to ask me whatever you are interested in, from post-market surveillance, from medical device, from application of artificial intelligence, machine learning, and other expert systems. I will be more than happy to reply to all of you. Enjoy the conference and see you soon. Goodbye and best regards from Sarajevo.